Our sun looks nothing like a bright yellow ball of fire. In fact, it's not yellow at all. It's green, sort of. Scientists determine the temperature of a star by the color spectrum it emits. Each color has its own wavelength, and astronomers measure these wavelengths to determine how hot a star is. Cooler stars appear red, while the hottest stars shine blue. Our sun emits most of its energy at a wavelength close to green, but because it also emits other wavelengths, these colors mix together, and our eyes perceive this vibrant mixture as white. If you were to view the sun from the International Space Station, it would appear white. However, from Earth, the sun looks yellow because our atmosphere scatters blue light, with the blue wavelengths scattered away. The remaining colors combine to create the yellow hue we see. If our sun were truly yellow, it would be about 800 degrees Celsius cooler, causing our solar system's habitable zone to shrink and Earth to become a frozen, lifeless rock. But that's not the only misconception about the sun. While it's incredibly hot, it's not on fire. Burning is a chemical reaction that requires oxygen and fuel. But the sun is not made of materials that burn. Instead, it's a massive ball of gas, primarily hydrogen and helium, with very little oxygen. The sun functions like a gigantic nuclear reactor, constantly fusing hydrogen atoms into helium in its core. This process releases enormous amounts of energy, making the sun scorching hot. Speaking of fire, let's talk about explosions in space. Contrary to what movies show, spaceships can't explode in a fiery blast in space because there's no air. And no air means no oxygen, which means no fire. Sorry, sci-fi fans, but those dramatic explosions are just for show. You might think the night sky is filled with too many stars to count, but scientists at Harvard have already done it for us. According to the Yale Bright Star Catalog, there are 9,110 stars visible from Earth with the naked eye. Go ahead, try counting them yourself. And while movies often depict asteroid belts as dense obstacle courses of death, the reality is far less dramatic. The asteroid belt between Mars and Jupiter contains trillions of space rocks, ranging from dust-sized particles to objects a quarter the size of the Moon. About 100,000 of these asteroids are over 1 kilometer wide, but they're spread out over a vast area. The asteroid belt spans 225 million kilometers, 1.5 times the distance between Earth and the Sun. This immense space means the asteroids are millions of kilometers apart, making it nearly impossible for a spacecraft to collide with one. If you were ejected into the vacuum of space, you wouldn't instantly freeze or explode. Freezing requires heat transfer, and in the vacuum of space, heat doesn't travel quickly. Your body would eventually freeze, but it would take hours, and by then, you'd already be dead from lack of oxygen. You also wouldn't explode, but you would inflate. Nitrogen in your bloodstream would form bubbles, causing your body to puff up to double its size. However, the real killer would be the lack of oxygen. After just 15 seconds in space, your brain would be deprived of oxygen, and you'd lose consciousness. Within 2 minutes, your organs would begin to shut down, one by one. Game over. Space might seem incredibly cold, but in reality, it doesn't have a temperature at all. Temperature is defined by the movement of particles, and in the vacuum of space, there are no particles to move. However, space isn't a perfect vacuum. It contains some particles and radiation, which can produce heat. Areas near stars are extremely hot, while regions farther away are much colder. Some dense gas clouds in space can reach temperatures as low as minus 263 degrees Celsius. Mercury, the closest planet to the Sun, might seem like it should be the hottest, but it's not. While its surface temperature reaches a scorching 430 degrees Celsius during the day, it plummets to negative 180 degrees Celsius at night. The true hottest planet in our solar system is Venus. Unlike Mercury, Venus has a thick atmosphere that traps heat, creating a runaway greenhouse effect. This makes Venus a hellish world with a surface temperature of about 475 degrees Celsius. Our solar system isn't stationary. It's hurtling through space at 220 kilometers per second, 7 times faster than Earth's speed as it orbits the Sun. It takes our solar system 230 million years to complete one orbit around the Milky Way. The last time we were in our current position in the galaxy, Earth had one supercontinent, and dinosaurs were just beginning to roam. Planets don't orbit the Sun in the way you might think. Instead, everything in our solar system is in a delicate balance. While the Sun is the most massive object, planets and moons orbit a central point between themselves and the Sun, known as the barycenter. For Earth, this point is so close to the Sun's core that it's almost negligible. But for Jupiter, the barycenter is about 55,000 kilometers away from the Sun's center, meaning the gas giant and the Sun orbit each other. Earth appears round from space, but it's actually an irregularly shaped ellipsoid. The planet bulges at the equator due to centrifugal force caused by its rotation. As a result, Earth is about 43 kilometers wider at the equator than at the poles. This bulge makes gravity slightly weaker at the equator, making it easier to launch spacecraft from equatorial regions than from the poles. In space, no one can hear you scream, but only to a point. Sound needs a medium to travel, and in space, molecules are too far apart for sound to carry. Cosmic events like supernovas and colliding black holes go silent before you could hear them. However, some regions of space, like the hot gas cloud around the black hole at the center of the Perseus galaxy cluster, have enough particles for sound to travel. This is what a black hole sounds like. If Earth were flat, it would be a very different world. Gravity, which pulls matter equally from all sides, would behave strangely on a flat Earth. The center of gravity would be at the middle of the disk, pulling everything toward it. The farther you moved from the center, the stronger the pull would become, making it impossible to reach the edge. Trees would grow diagonally as they reached against the pull of gravity, and rain, snow, and hail would fall toward the center, creating one massive ocean in the middle. Air pressure would be uneven, with too much air at the center and none at the edges, making it impossible to breathe in certain regions. A flat Earth also wouldn't have a geomagnetic field, leaving us exposed to solar radiation and causing our atmosphere to spill into space. Life on a flat Earth would be short and brutal. In this flat Earth scenario, the Sun and Moon would orbit the planet like spotlights. But this would create a world without time zones or seasons. If the Sun retained its current size, it would burn the planet to a crisp. If it were smaller, we'd freeze. A flat Earth would have nearly 2.5 times the surface area of our round Earth, meaning we'd receive only 1/3 of the Sun's energy, far too little to sustain life. The idea of a flat Earth is fascinating, but the reality would be a nightmare. Lunar eclipses are a fascinating phenomenon, but for flat Earth believers, they present a unique challenge. Flat Earth disciples propose the existence of an anti-moon, to explain lunar eclipses, as their model doesn't align with the traditional explanation. On our round Earth, lunar eclipses occur when the Earth positions itself between the Sun and the Moon, casting a shadow on the lunar surface. If the Earth were flat, however, this alignment would look drastically different, requiring a very specific and unlikely arrangement of celestial bodies. If the flat Earth conspiracy were true, if our globe was somehow photoshopped and GPS devices rigged for some hidden financial gain, it would open the door to countless other conspiracy theories. Unfortunately, many people, including flat earthers, live in a state of cognitive dissonance, where their beliefs don't align with reality. We're constantly bombarded with pseudo-evidence that can seemingly support any theory, no matter how illogical. If even Copernicus, the father of the heliocentric model, had spent 10 hours watching flat Earth videos on YouTube, he might have questioned his own discoveries. When we think of ringed planets, Saturn usually comes to mind. But what if I told you there are 3 other planets in our solar system with rings? Jupiter, Uranus, and Neptune all have their own sets of rings, though they're much thinner and nearly invisible from Earth. We only discovered these rings when Voyager 1 and Voyager 2 flew past them in the 1970s and 80s. Some scientists even believe Earth once had rings around 4.2 billion years ago, when a Mars-sized planet collided with our young world, ejecting debris that briefly formed a ring around Earth. Black holes, despite their terrifying reputation, don't go around sucking in everything in their path. They're more like cosmic sinkholes. If you get too close, you'll be spaghettified, stretched into a thin strand of matter before being lost to the void. But if you're far enough away, you're safe. Even if our sun were replaced by a black hole of the same mass, the planets would continue orbiting as if nothing had changed. The only difference? Eternal darkness. Speaking of darkness, the moon doesn't have a dark side. It's fully illuminated by sunlight at all times. But we only ever see one side because the moon is tidally locked to Earth, rotating at the same rate it orbits. If a large asteroid were on a collision course with Earth, you might think nuking it would be the solution. But that's actually the worst thing to do. A nuclear explosion would shatter the asteroid into millions of smaller pieces still headed for Earth, creating multiple impacts instead of one. Instead, setting off a nuke near the asteroid, not on it, could nudge it off course, saving our planet. Standing on Earth at night, you can see thousands of stars, but the view from the moon is surprisingly dull. Astronauts reported that stars aren't easily visible from the lunar surface because the moon's reflective surface creates a brightness that drowns out the stars, much like light pollution in a city. If you want a better view of the cosmos, you'd need to travel further into space. Space travel might make you temporarily taller, up to 5 centimeters, because the lack of gravity allows your spine to expand. But once you return to Earth, gravity brings you back to your normal height. And no, space travel won't make you age slower. While Einstein's theory of time dilation suggests that time passes slower at high speeds, you'd need to travel near the speed of light to notice any effect. With current technology, the difference is negligible. Crying in space is possible, but it's not the same as on Earth. Without gravity, tears don't fall. They form blobs that stick to your eyes, potentially obscuring your vision. Martian dust storms, on the other hand, are a real headache. The fine dust particles can get everywhere, and while they can't physically damage equipment due to Mars's thin atmosphere, they can cover solar panels, forcing rovers into power-saving mode, and inhaling that dust, not recommended. It could have serious long-term effects on your lungs. The twinkling of stars, as described in the famous children's song, is an illusion. Stars don't actually twinkle. Their light is steady. The flickering effect is caused by Earth's atmosphere, which deflects the light as it passes through. Similarly, asteroid belts aren't the dense, dangerous fields depicted in movies. In reality, asteroids are millions of kilometers apart, making collisions extremely unlikely. The Great Wall of China is often said to be the only man-made structure visible from space, but that's a myth. While you might see it with a zoom lens, it's nearly invisible to the naked eye. However, other structures like dams, bridges, and city lights are visible from orbit. There's a mysterious region in space known as the South Atlantic Anomaly, SAA, often called the Bermuda Triangle of space. This area, stretching from Chile to Zimbabwe, has a weaker magnetic field, allowing higher levels of radiation to penetrate. Spacecraft passing through the SAA can experience malfunctions, and astronauts are at risk of radiation exposure. To protect themselves, astronauts use water walls, massive bags of water that shield them from harmful radiation. The SAA is growing and even splitting, posing challenges for future space travel, but it would take millions of years for significant changes to occur. In 2010, an astronaut on the International Space Station captured a video of the moon appearing squished. This optical illusion occurs when the moon is viewed through the thickest part of Earth's atmosphere, bending the light. But what if the moon were actually flat? A flat moon would require an impossibly fast spin to form, likely tearing it apart before it could stabilize. If it somehow survived, its reduced mass would weaken its gravitational pull, drastically altering Earth's tides. Coastal ecosystems would suffer, and the ripple effects could decimate marine life worldwide. A flat moon would also fail to stabilize Earth's axial tilt, leading to chaotic climate changes. In short, a flat moon would be a disaster for life on Earth. When warm waters travel from one area to another, tidal forces play a crucial role in shaping global weather patterns. Without strong tides, we could experience extreme temperature fluctuations, disrupting ecosystems and weather systems worldwide. But even with these dramatic changes, the climate wouldn't shift as quickly as the length of our days. The moon's mass influences Earth's rotation, giving us a 24-hour day. However, if the moon were flat and less massive, our days could shrink to just 15 hours. While a shorter workday might sound appealing, the nights would be darker and colder. The moon reflects sunlight, creating the soft glow we associate with nighttime. A smaller, flatter moon would reflect less light, making nights significantly dimmer. This would disrupt nocturnal animals that rely on moonlight for navigation and hunting. But even these challenges might pale in comparison to the ultimate threat. A flat moon could crash into Earth. The Earth and Moon are locked in a delicate gravitational dance, each influencing the other. Tidal forces not only move our oceans, but also affect the Moon's orbit. The tidal bulges in Earth's oceans rotate faster than the Moon orbits, transferring energy from Earth to the Moon and causing it to drift away at a rate of 3.82 centimeters per year. A flat moon with less mass would orbit closer to Earth, increasing the risk of a catastrophic collision. Even if it didn't crash into us, A flat moon would ruin one of nature's most breathtaking spectacles, the total solar eclipse. Currently, the moon perfectly aligns with the sun, blocking it entirely during an eclipse. A flat moon wouldn't be able to fully cover the sun, leaving the top and bottom edges visible. A flat moon would disrupt the balance of life on Earth, threatening every ecosystem and living organism, including humans. Billions of years ago, a Mars-sized planet called Theia collided with Earth, an event so colossal it may have created our moon. This collision could have also brought alien life to our planet. Evidence of Theia might still exist deep within Earth's mantle, in the form of massive blobs of material known as low shear velocity provinces. These blobs, located beneath Africa and the Pacific Ocean, could be remnants of Theia fused with Earth. But some theories suggest an even more extraordinary possibility: aliens living inside Earth. The Hollow Earth theory, dating back centuries, proposes that our planet could be a series of nested spheres with a central core, capable of supporting life. Some even speculate that advanced civilizations of superhumans or humanoid aliens could thrive in these hidden realms. However, the reality of Earth's interior is far less fantastical. At 2,900 kilometers below the surface, temperatures reach 3,700 degrees Celsius, and pressure exceeds 237,000 times that of the surface. Any life forms there would need to survive without sunlight, extracting oxygen from magma or relying on radiation for energy. While the idea of a lush underground paradise is captivating, the truth is likely layers of molten rock. On Mars, the search for life continues. Just north of the Martian equator lies Jezero Crater, a 45-kilometer-wide impact site believed to have once been an ancient lake. NASA's Perseverance rover landed here in 2021, searching for signs of past or present life. Scientists believe that Mars and Earth have been exchanging materials for billions of years, meaning microbial life from Earth could have hitchhiked to Mars on comets or meteorites. If life exists on Mars, it would need to be incredibly resilient, capable of surviving extreme radiation and freezing temperatures. Microbes like tardigrades or spore-producing bacteria on Earth offer clues about how Martian life might endure. Perseverance uses advanced tools like the SuperCam, which uses lasers to analyze rocks and soil for organic molecules. If the rover detects signs of life, NASA plans to bring samples back to Earth for further study. This mission could revolutionize our understanding of life in the universe, much like Copernicus's heliocentric theory transformed our view of the cosmos. Even if no life is found, the samples could provide invaluable insights into Mars's climate history and help us better understand Earth's past. The possibility of life on Mars raises profound questions about our place in the universe. Are we alone, or is life more common than we think? The discovery of life beyond Earth would be as groundbreaking as the discovery of DNA, reshaping our understanding of biology and our place in the cosmos. But even if Mars proves to be sterile, the search for life continues to push the boundaries of science and exploration. Whether it's a flat moon disrupting Earth's balance, aliens hidden deep within our planet, or microbial life on Mars, the mysteries of the universe remind us of how much we have yet to discover. The search for life on Mars is not just a scientific endeavor, it's a journey that challenges our understanding of existence itself. If Perseverance were to uncover evidence of life, it would be a monumental moment in human history, akin to the discovery of DNA or the realization that Earth is not the center of the universe. But even if the rover finds no signs of life, The mission is far from a failure. The rock and soil samples collected could reveal critical details about Mars's geological and climatic history, offering clues about how planets evolve and what conditions are necessary for life to thrive. This knowledge could help us better understand Earth's past and future, especially as we face climate challenges of our own. The idea of colonizing Mars has moved from science fiction to a tangible goal, thanks to advancements in rocketry and space exploration. Establishing a human presence on the Red Planet would be one of the most ambitious projects in history, requiring unprecedented innovation and collaboration. But before we can build cities on Mars, we need to answer fundamental questions